Welcome back. We're on page 2, more graphing rational function goodness, where we're going to go ahead and do our 3 zeros, our big X test, our freshman graphing, and try to fit a curve appropriately to our asymptotes. So numerator equals 0. That happens when x equals -1, which implies that very likely at -1, 0, we might have a point right here. I put in -1, the numerator is 0, just so long as we don't have a hole in the graph. That's coming soon. Denominator equals 0. Well, the denominator equals 0 when x equals 0 or when x equals 4. Do we have a hole in the graph? No, because these don't match that. We don't. Now I can take care of this guidance. Put in -1. No matter what the denominator comes, it's not 0. We get 0 on something other than 0. It's just a point on the graph. These are our vertical asymptotes, x equals 0 and x equals 4. X equals 0, x equals 1, 2, 3, 4. Maybe I should have counted by 2's here. We'll see how that works out for us. We might have some regret there. And then finally, if x equals 0, I get 0 plus 1, 1 times 4, I get 4, over if x equals 0, I get 0 times, that's x can't equal 0. Look at that, x can't equal 0, so I don't get any new guidance there. Okay? And now big X becomes a contest of, becomes a contest of y equals 4x if we distribute versus x squared, which is 4 on x. And if x gets really, 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 really big, this wants to be 0. It wants to approach 0. Y equals 0. Now this is going to be a little confusing perhaps for a second. Y equals 0 is an asymptote. We have a point right on that asymptote. Guys, that can happen. We won't ever touch the vertical asymptotes. You can touch a horizontal asymptote. Horizontal asymptotes come into play when we get big positive, big negative, and we are certainly not big positive or big negative when we're close to 0. So that's actually a mole-man point. We can cross through that. Maybe we just touch it. Okay, well, we're going to definitely need some guidance here. We've gone through those 3 things. Y equals 0. We've got no guidance here, so the less guidance we get from those, the more freshman graphing we have to do. I definitely want to know what happens out here at 5. Or wait, 1, 2, 3, 4, yeah, out at 5. I put in 5. I get 5 times 6, 24 on. I put in 5, I get 5 times 1, 5. Put in 5, get out 5 fifths, 5, 10, 15, 20, 24 fifths right there. And I'm going to claim that's enough. I look like, maybe a little more curvy than that. We look like that, and perhaps I should have counted by 2's. But we've got a curve up there. I can't cross through here, not because it's an asymptote, because of mole men. Can't pass through. There's no more zeros. I think I want to know what happens at 2. Put in 2 for x, and I get 4 times 3, 12 on 2 times -2, -4, I get -3. 2 gives me -3. Now, maybe I want to say, well, let's figure out what happens at 1. If I put in 1, I get 4 times 2, 8 over 1 times -3, -3. I get 8 on -3. Was that right when I put in 2? I put in 2, I get 12. I put in 2, I get 2 times, -2. I put in 1, and I get 8. Put in 1, and I get negative 3. Negative 3/3, 6/3, negative 8/3. We actually look like this, kind of surprising. Now, do we pass back through there? Do we pass up through here? We don't. We have to be coming back down this way because of mole men. And we have to be going down this way because of mole men. You could go ahead and put 3 in there. But there's our curve that we've got. And now what happens over here? Wow. I'm going to put in negative 2. If I put in negative 2, I get 4 times negative 1, negative 4. If I put in negative 2, I get negative 2 times negative 2 minus 4. I get negative 2 times negative 6, negative 12. I get positive 1/3. So I put in 2, I get positive 1/3. And now, if I put in 1/2, I got a bit of a mess, and this is going to be a really, really cool reference to some stuff we've done earlier in this chapter. I'm going to tell you, I know it must go down through here. Why couldn't it touch and come back up? It could, however, look at this. This negative 1 is a single 0. It just passes through. But if you're not certain, you're going to put in 1/2. But this thing looks like this. It escapes the asymptote for a little bit, but is that the highest it goes? I don't know, but I know eventually it's going to get pulled back into it. Definitely a good problem for you to check on your calculator. Interesting one, kind of out there compared to some of the others on this page. Now, when you do 27, you're going to need to factor the denominator, set it equal to 0. You're probably going to get a couple vertical asymptotes here. Let's take a look at 29. Numerator equals 0. That's x times x plus 3 equals 0. That gives me x equals 0 and negative 3, which means I expect a point at 0, 0, and I expect a point at negative 3, 0. However, maybe not. Maybe there's a hole in the graph. Denominator equals 0. X plus 3 times x minus 2. X squared minus 2x plus 3x. Yep, that's x equals 2 and negative 3. Do we have a hole in the graph? Yes. Hole at x equals negative 3. That means negative 3 is not necessarily 0, and negative 3 is not a vertical asymptote. So put in 0, get out 0. Vertical asymptote at x equals 2. Hole in the graph at negative 3. Going to try to give myself a reminder when I graph this thing, wherever the graph's going, I've got a hole in the graph along here, but it's not a vertical asymptote. It's just a step over. All right, said that one was coming up. And how about when x equals 0, the numerator is 0, and the denominator is not 0, we get 0, 0, but we already had 0, 0, so no new guidance there. All right, well, I need to figure out what's going on here, big X. Let's see, I think I can fit that down here. Big X test pits x squared versus x squared, that's 1. We have a horizontal asymptote, y equals 1. All right, so there we go. Let's get a little bit of guidance here. Let's get 1 point absolutely for sure I think you should have on here would be one choice for freshman graphing should be 3. I put in 3 and I get out, let's see, 9 plus 9, 18, on 9 plus 3, 12, minus 6, 6, we get out 3. Put in 3, get out 3. I believe we look like this. And we cross through that. That's a single zero. X times x plus 3. 0, 0 is just a single zero. I believe we're going to get sucked into here. And I've just made a mistake. Did it intentionally. I mean, oftentimes I don't. But don't forget to come back here and illustrate that hole. Don't just say it's a hole over here and not illustrate it. That's, you know, if you say it here and don't put it there, maybe just 1 point off. If you don't recognize it's a hole here and don't put it there and don't state it, then I might take 3 points off for missing that. It's a big deal. Okay, when you set the numerator equal to 0 here, you're going to factor that. Going to get a couple places where it's 0. However, I think this one's going to have a hole as well. Just looking down the road as far as how that factors. So there you go. And let me know what I can help with.